Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
Now the thing about rotational path concepts is basically it's the cover of your book. So for those of you that have got the Kroll manual, I mean, the picture that's right on the cover of your Kroll manual shows both an upper rotational path and a lower rotational path. So that's just the cover straight off your book. And so we'll go over it. If this were a standard class 3 partial denture, the lower picture, if you had a molar on each side and then you went up to a first bicuspid with this longer span, if it were a conventional class 3 partial, that is a non-rotational path partial, the path of insertion for the partial would be straight up and down. Now sometimes some of you that have worked with lower partial dentures, where you've got these teeth at the back end for the lower partial, you may not be aware, many times when you've got these situations in the mandibular arch, this lower posterior tooth is very often tilted mesially and lingually. How many people have had one of those? Either for a crown of bridge, you've seen those, where you've got this lone standing molar in the back, and it's sort of leaning mesially a bit, and it's leaning lingually a bit. And so if you're thinking of trying to survey that case to give you a nice straight path of insertion, it's reasonably difficult because many times where the tooth is leaning lingually, if you're trying to find a path of insertion that will let your partial denture come down past that lingual cusp of the tooth, when it gets down to the inferior edge of the framework, it's nowhere near the tissue. And you say, gee, I might have a hard time uprighting the lingual of that tooth enough. And similarly for a mesial tilt. In the upper case, as is shown right on the cover of your book, you can see many times if you've got a class 4 partial denture, upper class 4 replacing anterior teeth, one of the downsides of any upper partial or an upper partial replacing anterior teeth are these guys right here, that is the clasp. Now I would argue that the way they designed the clasps on this particular partial looks reasonably good in that the clasp is an infrabulge clasp, so it stays up high and it contacts the tooth very near the pregingival margin, so that's not an extremely ugly clasp as clasps go. But many times you may be able to find a situation in which you can do a rotational path partial and eliminate the clasps on the anterior aspect of the partial completely. And in this case, it would be a front to back rotation. In the lower example that you see for the class 3, it's the posterior seats first, and then once these rest seats are in place, you just rock the anterior down in. And when this has happened, if you seat the posterior rest seats first, rock the anterior down in, when it's fully seated, the proximal plate back on the molar literally takes advantage of the fact that there's an undercut on the mesial of the molar. It uses it. So you sort of seat the partial in the back first, rock it down, so now when it's fully seated, the back can't come up because you have engaged the proximal undercut. In the situation here, it's a similar situation, only from front to back. And we'll talk more about that later. So what are general considerations? If you've got a rotational path, all of your rest seats do not necessarily seat simultaneously. It's not a straight path of placement. It's a curved path of placement. Many times you can eliminate anesthetic clasps. The clasps are replaced by rigid retainers. What do we mean? In the case that we talked about before, in the posterior aspect here, no need for a clasp here because the rigid retainer, meaning the proximal plate of this partial denture framework, once the partial denture rocks down in place, there's a good occlusal rest on this, and then the proximal plate locks into the undercut. So as long as the partial denture can't move mesially, this can't come up. It's locked in. As long as this stays down, this is locked in. So clasps in this case would be replaced by a rigid retainer. What do I mean? The proximal plate and the occlusal rest. So we don't plan on the retainers flexing. If it's a clasp, you plan on the clasp flexing over the height of contour and coming to rest at the desired amount of undercut. If it's a rotational path, that part of the rotational path framework that seats first and you rock it to place doesn't really flex at all. It's a rigid retainer. Just by going in and rocking to place, it locks itself in. And so the rigid retainers do engage undercuts, and with many of these there is little tolerance for error, because if these are off just a bit, there can be problems. How many people so far have delivered a definitive partial? I mean, a partial that's got a metal framework and you process teeth on. Half of you? 2/3 of you? A little less than half. So for those that have, or for the people that are about to deliver some partials, what often happens is you try the partial denture framework in to make sure it fits okay, and you take a bite registration. So you say, gee, Dr. Shotwell, the framework fits pretty good. We got the occlusion adjusted, and we took a bite. Now you come back and you go to deliver the partial with the teeth processed on. And very many times when you go to deliver the partial, now that the teeth are processed on, you come and get and you say, gee, my partial denture won't seat. I can't get it to place. What's the only thing that's changed? It's we got teeth and plastic on it now. So in many of those situations, what happens is where the plastic has been processed, meaning when there's a tooth set on here and there's pink plastic processed in here, many times as you're trying to seat the partial, the pink plastic flange interferes with the undercut you're trying to engage. And so, as with many of these, there's not a lot of tolerance for error. Why do we always have you people orient your partially edentulous cast on the surveyor table so that it's level front to back and level side to side? We talk about this over and over. So sometimes in the pre-clinic even, and in the books that they were talking about at the time I was in school, I was always sort of left with the impression when I took partial denture in undergrad that if you put a cast, just took a model out of a patient's mouth, took an alginate, poured up, mounted up. If I fiddled with this thing enough on a surveyor, if I dinked and fiddled around, I could find some orientation of this cast that would satisfy all the requirements that were necessary to make a nice partial denture framework. I was just always too dumb to find it. But supposedly if I dinked enough, well, really what should have been happening is you just orient the cast so that the occlusal plane is level front to back and level side to side. Draw a design that would be my most ideal framework design that I'd like to draw. Forget the contours of the teeth, just draw a nice design. Now go back and look at the teeth, now that you've got your design drawn, and say, which areas of the teeth are going to work with the design I've drawn, and which contours on the teeth, typically axial contours, are fighting me, are not working with the design I've drawn. Now the reason we want to orient the cast level front to back and level side to side is if I want an undercut, where I'm looking for the desirable undercuts where the clasps are going to be. Again, when do we want those clasps to engage? We want the clasps to help hold the partial denture in place, to resist the tendency for the partial to be pulled out of the mouth when eating sticky foods. So anytime you're eating sticky foods, once your teeth come together, when you start to open your mandible, open your lower jaw, during the first millimeter to 2 millimeters of opening of your lower jaw, can everybody see that the direction that your lower jaw is going to move is pretty much perpendicular to the occlusal plane? I know the jaw opens on an arc, I know that. But can you see just the first 2 millimeters of movement? That first little teeny bit is pretty perpendicular to the plane of occlusion. And once you've opened 5 or 6 millimeters, the partial's already off the teeth. I mean, if you're eating a jujube or a gummy bear, by the time your front teeth are 5 millimeters apart, the partial's already completely unseated. So it's just during the first couple millimeters of opening is when you want that resistance to displacement. And so since during just the first millimeter or 2 of opening, if there's some sticky foods in here, the direction of the vector is pretty nearly perpendicular. So I want to find out where the desirable and undesirable undercuts are for my proposed partial, perpendicular to the plane of occlusion. Because if I can do a lot of gymnastics, if I can really orient the surveyor table all over the place to try to find some orientation where I can pick up retention. The point is that's not the direction that people are going to chew. Okay, when they open their jaw, the vector is not going to go over this way somehow. It's going to come straight up here. So if I orient my cast in some odd orientation to find an undercut, but when I bring my cast back level, front to back and side to side, if that undercut now goes away, that's a false undercut. Because a false undercut is one that you can orient the cast somehow to find it. The question is does it still exist when the occlusal plane is level front to back and side to side? Because that's the direction that the removal torque of sticky pools is going to pull on the partial. People follow that concept okay? So how we're always orienting the cast is just dump the thing as easy as can be. Put it on the darn framework, level front to back and level side to side. And then start analyzing the contours of your proposed abutment teeth to say, gee, do they tilt lingually? Do they tilt lingually so far that it would be difficult to see the framework? Because it's difficult to get it past the tooth and still have it touch the gum. Many times if they lean lingually so that the lingual of the tooth is in the way, what do you suppose is the situation out at the buccal of the same tooth in terms of undercut for your clasp? It ain't there. Everything's leaning lingually. So you're just looking at the orientation of the teeth when we've got things oriented, when basically our casts are level front to back and level side to side. And again, these pictures, I'm not going to go over these things in a ton of detail because these are all straight out of your book. I just scanned them. And so the thing here is we talked about if you've got a linear path of insertion, everything goes up and down at the same time. If there's a mesial undercut here, you block it out parallel. If there's an undercut here, you block it out parallel. So the whole framework could go down level, and everything engages at the same time. If it's a curvilinear path of insertion, or a rotational path, the back end seats first, and then the front end rocks in. Now, can people see that if you're going to do your blockout for this, one of the things you need to figure out with your blockout is on the distal side of this front tooth, you can see that this is going to go on an arc. So if you had a pair of dividers, and you put one arm of the compass here, and you put the other arm of the compass so it just barely touched or grazed the distal marginal ridge of that tooth, and then you arc that divider down. This dotted line, you'd have to block that out. Because if your framework tried to fit any tighter to the distal corner of this tooth down at the cervical, can you see that when you seated the posterior part and tried to rock it into place, it wouldn't seat at the front? That part of the proximal plate that's right here, if it wasn't blocked out per this dotted line, if it fit tighter to the distal of that tooth, it wouldn't rock into place when you're seated. So those are the things you want to look at when you're blocking out for a rotational path, not you, but the things you're thinking about in terms of contours for the teeth. Okay, in the linear placement, again, all rest seats simultaneously. So if it's not a curvilinear, if it's not a rotational path, it's just a straight up and down path of insertion, for the most part, all the occlusal rests seat pretty nearly simultaneously. And you can see in this area, you would have blocked out where that undercut exists on the mesial of that tooth and where the undercut exists on the distal of that tooth. They would have been blocked out parallel with the path of insertion. So when everything went in, it just all slides down. And then what's holding this partial denture framework to the back tooth is an occlusal rest, a lingual reciprocal arm you see dotted, and a buccal clasp arm. So if you said, okay, in the same situation, if there's a little bit of an undercut on the mesial proximal of that tooth, what if I go ahead and do a curvilinear path of insertion so that my block out at the mesial of that tooth is entirely different, and I'm planning completely on having my proximal plate fit that more intimately. There's still block out here to allow that arcing type motion to come down and clear the distal of that tooth. But there's not as much block out here. There is no buccal clasp arm. There is no lingual reciprocal arm. But when the partial denture is fully seated, this distal part can't come up in the air because this proximal plate is wedged or captured in that undercut on the mesial. So it's an intentional use of an undercut without blocking it out. That's the whole idea of rotational path partials. What types have you got? You got front to back, you got back to front, and in some situations you can do them sideways, sort of, okay? So if I do basically from front to back, that is very similar to the one that's right on the cover of your Kroll manual. Again, if you look at that upper set of pictures, it shows the case where you've got a patient that's got anterior teeth being replaced. When that partial denture goes to place, the front is going to seat first, and then the back is going to rock in. So that's going to be front to back. Okay? We've got back to front. And that's the same one that's sort of shown on the cover, that you seat the back first and then you rock it to the front. So you either got back to front or front to back, and sometimes you can have a lateral path. So you've got some teeth missing right here, so you're missing basically a lateral incisor and a cuspid. And instead of doing a fixed partial denture there, it's thought, okay, can we fit a partial denture framework in there, and then basically let this part seat down first, and then arc or rock the partial denture down to get a clasp to engage over here. So as long as this part of the partial denture stays seated, there's a couple of undercuts that have been engaged over on this side by rocking into them. So as long as this side stays fully seated, these things can't lift up in the air because we sort of rock them into an undercut. We rotated them in. Categories, we got category 1, category 2. Category 1 is more like the picture that we showed you at the very top of the lecture of the lower class 3 partial, where the posterior rest seats would seat completely. The posterior rest seats would seat completely, and then you'd rock the partial to place with those rest seats acting as a fulcrum, basically. A category 2, or dual path, instead of a pure rotation path, was more similar to the picture on the front cover of your book. That's the upper case. So the way that one works, if you've got one of these class 4s and you're trying to make use of undercuts on the mesials of the cuspids or the mesials of the first bicuspids, you seat the partial denture in an anterior angulation so that the end of the flange sort of sits down first, and then you rock it in. So the rest seats themselves don't hit right away. You don't seat the rest seats and then rock it around the rest seats. You follow that okay? In the back to front one, the rest seats are fully seated, and then you rock it into place with the rest seats seated. That was that lower class 3. The upper class 4, the rest seats are not fully seated when you're angling it in from that front direction. You get the edge of the flange all seated, and then as you rock it to place, during the rocking to place, the front rest seats seat, and then just a little later, the posterior rest seats seat. But in the type 2 or the category 2, your rest seats aren't fully seated on the rotational part. You seat it in, and that's a dual path of insertion, sort of being seated at an angle and then rocked in. And so here's a category 1 like we talked about. It's basically these rest seats seat completely. This would be a class 3 partial going around to the other side of the arch. So this rest seat seats completely. You rock it down in place. So when this is seated, this wedges into the undercut. Okay, we look at basically a category 2. Sometimes in these situations, if you would imagine this to have anterior teeth set out in the front, and that again is the picture on the front of your manual. And so what would happen in these situations is, as it was being seated in, the front part seated first, the end of the flange would sort of fit up in here, but the rest seats themselves would not fully be seated. So we angle it in on this forward angulation this way, seat the flange in, start rocking it down, and as it's rocking down to place, later on then the front rest seats come to rest, and then last of all, the back rest seats come to rest. So it's first the flange is going in, then we start arcing it, and then the rest seats in the front part seat a little bit later, and the back rest seats seat last of all. But in the category 2, which whether it's back to front or front to back, we don't completely seat the rest seats, and they're not the fulcrum for the rest of the rocking into place. What do we want to look at when we're doing cast analysis? It's basically sort of like any partial that we'd be doing. You're going to look at your plane of occlusion, and when you're looking at the plane of occlusion, we sort of talk about that stuff, but as you've got a set of casts on the, if you've got the amount of casts, what's that really mean? If you're assessing the plane of occlusion, can you see that if it really goes up and down a lot, that's not a good thing? where some teeth have gone missing. So let's say the posterior lower teeth have extruded up in the air, and some unopposed upper teeth have gone down. So your plane of occlusion sort of does one of these. That's not such a good thing. How can I correct that? What if your plane of occlusion has the posterior molars extruded and tilted along with it? So it seems like when you sort of look at your lower plane of occlusion, it seems fairly reasonable at the front, but as you get toward the back of the mouth, it like really curves up in the air a lot. So your overall plane of occlusion is really like a ski jump going up there. Not such a good thing. Maxillary plane of occlusion. Some posterior teeth unopposed and extruded down quite a bit. So your maxillary plane of occlusion sort of goes level across here and then dives way downhill. Not such a good thing. So look at your plane of occlusion. How long is the edentulous span? Again, many times what people will look at is that the edentulous span is fairly short. One of the things you're thinking of is, what if I just do a fixed partial, a bridge? There are some situations in which the edentulous span gets longer. The amount of stress you're going to potentially put on your abutment teeth if you do a fixed partial denture is a lot. And so those may fail over time. You might not just trash the teeth. Can people think of other possible problems with a really long span bridge that has nothing to do with losing the teeth or putting too much stress on them? How many people have delivered a crown and not that much later the porcelain fractured off? Anybody have one of those? Anybody have one that they inherited from a senior that graduated last year? So you didn't do it. The patient's back, and one of their complaints is a bunch of the ceramic fractured off my bridge that was just done last year. Well, that kind of stuff happens as you get longer span bridges. How come? Because the substructure may flex a little bit. And if the substructure flexes a little bit over a long span, and the overlaying ceramic doesn't, then it's going to develop stress fractures and fall off. So length of span is sort of an issue. As spans get fairly long, they're almost easier to do a rotational path. Why? As spans get pretty long, if I were to imagine a molar, and let's say I had a fairly short span, not that I would do this with a rotational path, but I've got a short span to a bicuspid and a bicuspid, and I'm planning on making a rotational path and seating this first and then arcing the partial denture down to place. Let's say I've got a similar case, molars the same way, I'm missing a bicuspid, let's say I'm missing a first molar, I'm missing a bicuspid, I'm missing a bicuspid, I'm now up to a cuspid. And I'm planning on seating here and then arcing things down here. Can people see that the longer the span gets this way, as this thing arcs forward, I need less blockout on the distal of this tooth with a longer span than I do with a shorter span. People follow that okay? If you look at imagining any circle that you'd have and take different diameters when you've got your compass. As the radius gets longer, any section of arc on here becomes more nearly a straight line. When it's a very short radius, your curvature here is pretty tight. So it takes a lot of blockout right here. When the arc is a lot longer, arc is not nearly so tight, you don't need to block out so much. So can people see how longer edentulous spans require less blockout when you're doing a rotational path? And really short spans are almost more of a bother if you're thinking about rotational path concepts. And then the shape of the dental arch and how much undercut are we working with. So again, when we look at plane of occlusion affects the depth of the undercut. So we look here, and again, these are all in your book, so it's sort of like, where do we locate the undercut on these things for the plane of occlusion? Length of the span. This just sort of looks at that one situation saying, if you're doing a front to back, if you're doing like the upper picture that's a class 4 partial, and things are going to seat here first and then rock down distally, the shorter the span is, the more you've got to block out. And the further away you are, so that radius, the radius of arc that you're going on, as that gets longer, you've got less block out because things are becoming more nearly vertical, whether that's upper or lower. If the rotational axis is fairly straight across the arch, side to side, and looked at from the front, it's also fairly level. What happens when this partial denture is going to rock to place, it's going to rock pretty straight down in place. Could you see that if it was a situation in which the posterior plane of occlusion was uneven from side to side? Let's say, for whatever reason, this tooth sits taller in the air than this tooth. And so instead of going like this plane runs downhill like that. Can you see that if the plane is tilted like this, when the thing rotates, it's going to rotate diagonally coming down? People follow that? So the height up and down of the posterior teeth you're rotating around also matters. Because if they're at the same height, things are made level. They're at the same height. You seat the posterior part, you rock it down. Your arc of seating is fairly straight down. If the two teeth at the back that you're using as your primary rest are significantly not level in height, so the plane runs this way, can you see when it arcs forward, it's going to arc that way? And that can cause you problems on how you would block out or how well it seats on the anterior teeth. So it's basically the position of your rotational axis, both in terms of is it straight across and also is it level? Because again, imagine that you were on two different teeth here and it was pronouncedly angled that way. So again, that would affect how the rotation happens. Sir, question?
I just have to decide how well is this working patient? Like how
if it was just sucked, nobody would do it. And so the thing with this is labs really have to, both the treating dentist and the labs have to be up to speed, but they work really well.
How does the patient define it? Are elderly people able to, is this the right rotation?
Pretty much. The only thing is, and the question was, are these so complex to put in that people have a hard time doing them? Not really. They go in as easy or easier than a conventional partial. Because let's say with a conventional class 3, in this situation right here, you've got 4 sets of clasps all grabbing the teeth. And so as far as how tight this thing is going in, can you see both seating it and taking it out? You're working against the retentive features of 4 different clasps grabbing the teeth. People follow that okay? If it's a rotational path, and literally when people toss them in, after about 2 days, they get real used to just sort of feeling how it goes in. Because it's not that it's a lot harder to put in, it just doesn't go absolutely straight down. They've got to consciously just let the back part seat and push the front part down. But it really does wind up that they're real finicky to design, and for the lab to do them so that they work well, they're finicky. But if you find a lab that can work that way, they really do work quite well. And in many of these cases, so again, where you've got the mesially and lingually tilted molar, it's real easy to do these kind of partials instead of trying to fight and find some way to figure out how you're going to get your framework to fit around those tilted molars for you. So again, they're a little more challenging to design, and your lab has to be on their game to make these things so that they come out well, but when they do, they aren't any harder at all for the patient to physically place and take out. Actually, they're a little bit easier. They're a little bit easier. And the shape of the arch. The more V-shaped the arch is, you block out different areas. Because if the arch is pretty much square and straight front to back, you don't have to block out that much on the lingual of the teeth. If the arch is real V-shaped, then when this thing arcs down, you got a little more block out to do on the distal lingual. Again, all this stuff is in your book. If you're looking at your undercut, then what you want to see is basically, if this were a class 4 partial that you were going to do, this is just like the one that's on the cover of the Kroll book. So if you were saying, I want to go ahead and not show clasps in the front, if you had everything square with the world, you would say, okay, I got some undercut on the mesial proximal of these cuspids, for example. Cuspids are first bicuspids. The other thing you want to look at when the survey is level is to say, how much undercut do I have at that back tooth? Okay, would anybody care to tell me if I have a problem with that undercut right there, what's my problem? I want some undercut, that's a good thing. So I've got some undercut, but what's wrong with the nature of the undercut? Can you see that my height of contour is absolutely at my occlusal buccal corner? And I'd like the height of contour a little bit further down on the buccal of the tooth. So can you see if we took a high-speed diamond and just rounded the occlusal buccal corner of this tooth a little bit? So we still had undercut down here at the cervical, but our undercut was softer. There was a more gentle curve going into it. People follow that okay? Because again, if your height of contour is absolutely at that occlusal buccal corner, there's no gentle curve for the clasp to flex over and seat. And then when you go ahead and tilt the cast so that you're looking for your secondary path of insertion, you tilt the cast posteriorly till you see your survey shows that you've got no undercut here. So I'd say if that's my secondary path of insertion and that's my primary path of insertion, the total amount of undercut I have available to use is the difference between the two surveys. So in this particular case they used as illustration, I can pretty much work out a survey that will let me use the entire proximal of that as my undercut on my rotational path. So it's the difference in the undercut between the two paths of insertion that you pick up. So you go ahead and you put a set of marks on your cast for the level survey, and you put a secondary set of marks on there when it's tilted posteriorly. So there's two sets of survey marks on your cast. One sort of orienting things level, and the other one at the tilt you want when you've pretty much eliminated the undercut on whichever proximal surface you're using for your rotational path. The rest seat preparations on those mesially lingually tilted molars, they're mesially tilted molars. We typically do a channel rest or an elongated rest. And the reason we do those elongated rests is because we're not having any reciprocal arm on the lingual or clasp on the buccal. When the framework engages this elongated rest over time, the tooth won't tilt or move in partial. Can you see if I just had one little teeny circle, just a teeny little dot for a mesial rest, over time the posterior tooth could move a little bit around that rest. But if it's a long rest that fits in a channel, the tooth can't rotate or tip at all. And so in those situations for molars and then in the cuspids, it's a typical little chevron rest, or I'll many times even just use a flat rest that's positively inclined toward the lingual of the tooth. And so again, if you look at these things, if the teeth are tilted lingually, if you were to imagine taking a survey that would come straight down on the lingual of that tooth, to have your framework clear the lingual surface of the tooth, it has a hard time resting against soft tissue. So that elongated rest will just use the occlusal and the mesial proximal surface, and you don't care that there's no undercut on the buccal, and you don't care that the tooth is tilted lingually a little bit. And again, here's one of these sets of dividers or a compass that you can set up two different separations, and if you can make the two arms parallel to one another, then you can look at set one arm where your retina fulcrum would be, and when you rotate it down, you can see your blockout. So in these cases, the area inside the dotted line, or the area between the dotted line and the tooth, would be areas that would be needed to be blocked out for this partial to be, for the framework to be able to see when it's rotating in. Okay, so the blockout's just a little different on there. So we're just going to show just some different examples of patients. So here's basically, the back to front. So we go ahead and either one of these, you just seat the framework from the back to the front. There's your framework. We'll set teeth on, you process acrylic. But here's the strap rest in the back. So this seats first, rotates down to place, and the clasps engage. We go ahead and get the teeth set up on that. So right away here, you see it's all processed. You've just got this elongated strap rest on the posterior molar. You got a clasp up front, so this seats, rocks forward, clasp goes down. So as long as this is seated, the back part can't pull out, front to back. You go ahead and you look at these many times, these class 4 situations. Here's your lower arch. So we go ahead and get things set up. Here's our framework. So this framework engages the mesial proximal of those teeth next to the edentulous area. And then it rocks posteriorly and seats over the posterior teeth. I apologize for the burnout on these. And then the thing you see here is here's your replacement teeth, and what you've got here is no clasp. And so you've got a situation in which you're not showing any clasp. Here's an AP Category 1, meaning that you seat this framework completely here, and then just rock the clasp down to place. So here's the same thing, longer spans. We go ahead, front part of the framework seats down, you seat the distal down, no clasp here. We've rocked in at the distal of that tooth. We got a clasp back here where it doesn't show. Lateral, it's the same thing, they show you that in the book. Here's one from the clinic. It's basically, you're missing some teeth here, So we plan on laterally rotating from here across to here. And so we'll be clasping on these two. There's our edentulous span. We go ahead and have our framework made. And again, the framework engages the proximals of those a little bit. So what do? Your first survey is with everything level with the world. And what you're looking at there is the clasping you try to get on this tooth. And when everything's level with the world, the hope is that you're seeing some undercut on the proximals of those two teeth. So when things are sitting level, you're looking for where's your undercut on this tooth, and do we have an undercut on the proximals of this question?
What is the minimum
How much undercut? It's sort of like any daylight we can see is good enough. More is better. And so the thing is, if we've got much in excess of 10 thousandths, we may not need any more than 10 thousandths, 15 at the most. But let's say in a pinch, if you can see some daylight, when everything's level, this is oriented level in the cast, we see a nice undercut here, and we can see daylight on either of these proximals. And then when we do our secondary tilt, we tilt the thing laterally, and on tilting it laterally, we see the daylight disappear, and we see these things become perfectly parallel. Then that's our secondary path of insertion. So the total amount of undercut available to you on those proximal surfaces is the difference between level and tilted question.
When you're using this or more, how much is tilted? I know the more it's tilted too much, you want the force is on the long axis. Driving tilt more.
I do. And there's many photoelastic studies they've done, both for fixed partial dentures and for removable partial dentures. Depending on how a tooth is tilted, if this is true north and south, and the tooth is tilted this much, or it's tilted more severely this much, if you go ahead and you've got your strap in there, and if you're touching at all at the marginal ridge, even if there was more undercut than you could use, and you block part of it out so that your framework fits like that and it engages a little, as long as it engages at that marginal ridge coming around the corner a little bit, this tooth cannot tip easily because it's got a block there. And when they've done photoelastic studies on it, which they've done, vertical pressure right down here on these measly tilted teeth, when they're either held in place by a fixed partial denture or a removable partial that touches right there, the photoelastic studies tell you that the forces are directed right along the long axis of the tooth. Because it can't lean over any more measly because something's in the way, even if it's just the first 1.5 millimeters to 2 millimeters up by the marginal ridge. So if it can't fall measly, no matter how much you push down on it, the forces are directed down the long axis of the tooth. That's not an issue. Because they've looked at that for the last 40 or 50 years. And so here's that case basically in the mouth. You look at one side, you look at the other. They've got this one picture backwards, obviously, because this is the other side of the mouth. And what they're using here is the proximal and the proximal. And so there's the try-in, and you go ahead and get things processed so that you got the teeth on it here, and it just rotates in laterally. And that's the finish. Another lateral. It's got a longer span, same thing. You've got sort of a long span here. You can look at this and you can rock across to the other side of the arch. And there's the thing going. So the idea is, when you're looking at any case where you might think about using those, what you want to do is talk to your faculty and take a look at the case and decide whether rotational path is the way you want to go. Now, Swinglock removable partials, basically this is what the framework would look like, and there's this gate that fits around on the labial of the teeth with these little eye bars that come up vertically, and these little eye bars will engage the labial surface of the lower remaining teeth. Now, I don't use these all that much anymore. We used to do them a little bit in the old days, but I think pretty much now with high-speed instrumentation, you can reshape the contour of teeth fairly easily. And with bonded composite restorations without crowning teeth, you can also build up undercuts more where you need them. The other thing you want to know is that these frameworks will cost at least $200 to $250 more than your conventional framework. So from Zidane and those folks, it's not uncommon for the framework cost alone to be between $650 and $800. So if your framework cost alone, you haven't added teeth on it, you haven't processed any plastic on it. If your framework cost alone is pushing $600 to $800, you want to make sure that you're being remunerated enough for the partial that you're not losing money on it. There was one several years ago one of our grad students did for a nice patient, Mr. Trader. And so when we got the whole thing done on that, it was a very complex framework that overlaid the occlusal surfaces and everything else. We did the case, and we were charging Mr. Trailer basically the graduate fee for a partial denture, which is around $1,250, and the framework cost us $1,800. That's a great business plan, isn't it? Okay. You lose money on each one, but you make it up on volume, right? So here's a situation also where some of these, as I say, if you've got a situation that's more like a maxillofacial case that you do with Dr. Z, where the number of teeth missing or the amount of defect you're trying to fill up is very extensive, it may be that the extra grip with the Swinglock may be worthwhile. Now this is basically just a set of duplicate casts to go through the sequence of how one of these frameworks would be made, the standard blocking out. They're going to go ahead and duplicate it. Here's our study model, and we go ahead and say how we're going to wax the framework up. Here's the wax up of the framework. And the way the frameworks are waxed up is there are these stainless steel spindles that are incorporated into the wax up. And the reason this sticks up in the air as far as it does is just so it can fit in a dental surveyor, like a surveying tool. But what's going to happen is after casting, all of this stuff that sticks up in the air is going to get cut off. So all this is for is it's extra things to use it in the tool that seats these down. So the bottom part of these spindles will be incorporated into the framework, but the top 80% of these things is just cut off with a carburetor disc and made smooth in the finishing of the partial denture framework. So here's another view of the things. So here's your lingual plate, here's your meshwork, labial view, here's your two spindles. One side is going to be the gate side, that's going to be a hinge. And the only difference on these things is which one's the gate and which one's the hinge at the wax-up stage. If you look at the cast metal right here, this vertical part right here is the bottom part of this spindle right here. This part of the spindle right here is what you see here. The top part of where the spindle was here has been cut off and polished. And so where this has been cut off and polished is what stands up in the air. Now on one side, when they do the wax up of this, they carry the waxing all the way around that vertical spindle. On the other side, that's going to be the snap-in gate, the wax up on that side is going to only surround about a little more than 180 degrees. It's not going to surround all the way around that spindle. So one side is waxed up all the way around it, which becomes the gate side. On the other side, the waxing over here wraps around part of this spindle, but it doesn't go around at 180 degrees. Then when it's cast, there's just enough surface contamination on these that it will allow these things to open up and swing. It's not a problem. And so basically, here's your hinge side, so you can see when the waxing was done here, unlike the hinge side, on the other side, this waxing didn't wrap all the way around this spindle. Again, this spindle used to go up in the air, up into the surveyor, and the top part of it was cut off. So the only difference is this, instead of being waxed all the way around the spindle, was only waxed part way around the spindle, enough to get a snap fit on it. So the other thing is, because these are totally interchangeable, that is, which side you want to wax it all the way around and which side you want to wax it part way around, you can make these things open either way. It just depends on how they wax them up in the lab. So if you're thinking about doing one of these, you want to ask if the patient's right or left-handed, which side is easier for them to get a hold of this gate and snap it open if they have a preferred side. So here's a situation clinically in which you look at the teeth in the anterior. We go ahead and basically have our partial denture. Here's examples of them. So here's a Swinglock. Again, we don't need to do these so much anymore because nowadays with high-speed instrumentation and bonded composite materials, I can alter the contour of these teeth to make them more favorable fairly easily. So if you'd see these used at all, they would tend to be used in maxillofacial situations for the most part. And you say, golly, these are ugly. Doesn't this thing bother the patient's lip? And isn't that the dickens of a food trap? We find most patients that these have been done on, they notice it a bit at first, but they get used to it fairly quickly. Is it a food trap? Yes. But because the partial can be taken out and cleaned, and that's your hope, is that the patient will continue to clean these things. Surprisingly, with lots of patients, when they smile, where these eye bars are located fairly close to the pregingival margin, they're not aesthetically unsightly. So typically, here's a nice lady, there's her upper denture, but you don't see the lower Swinglock partial at all. If you've got the same thing but with a modification space, the modification spaces can be fitted on your partial, and the gates just fit around the modification spaces. Again, with the materials that we have available to us today, I can't justify anymore spending many hundreds more dollars for a framework like that when I can recontour the teeth to get a conventional partial pretty much the way I want. These situations might be a little more challenging where you've got all the teeth on one side. Again, this shows a situation where you're trying to clasp those teeth a little more firmly. So you've got these teeth clasped pretty firmly, and this is all replacement teeth. Again, the thing that's now available during your practicing lifetime, what I'd be thinking about rather than making a real expensive framework would be, in a situation like this, is looking over, I guess it's not like that. Is over in this area, is considering putting 1 or 2 dental implants over there, strategically located. And then you can have a partial denture that would sit in here. It's just under the partial denture framework in this area, you'd have a couple of zest locator attachments and it would just snap down. And again, when these frameworks were in vogue, we did not have that as one of our options. And so we can just look, here's another one that clasps teeth in 2 different ways. Again, these would get to be very expensive frameworks. They worked out okay. But like I say, I want to show you the Swinglock partials as much as anything. So if you've heard of them, you sort of know what some of the indications might be, mostly maxillofacial. And nowadays that we have dental implants available to us and the possibility of recontouring teeth much more easily, either by high-speed recontouring or using bonded composites, they're far less necessary. Thanks much.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.